So now let us solve certain difficult problems from quadrilateral. Now what am I being given? A rectangle ABCD is given to me, and I'm being told APCQ is a rhombus. So APCQ, if you can see it there, is a rhombus, and ABCD is a rectangle. So they will follow all the property of rectangle and rhombus. QP is nothing but the diagonal of the rhombus is something that is being asked to me. So let's complete this rhombus so that we can understand it better. So I'll draw this rhombus over rectangle so that my understanding of it becomes easier. I'll draw the two diagonals. One will be QP, I'm supposed to find out, and the other will be AC. Now what all is given to me? I am being given the two sides of the rectangle. One is 7 and the other is 24. Pythagoras triplet I'll apply it here because the angle is 90. So 7 square 49 divided by 2 24.5, 24 and 25. We learned this earlier, right? So one side is 24, so other side will, that is nothing but the hypotenuse will be equal to 25. Okay, that's what I get it at. So my hypotenuse, which is nothing but diagonal, which is nothing but the diagonal of a rhombus, is nothing but 25. But we have learned in rhombus, diagonal bisect each other at 90, right? I'll apply what we have learned now. So the diagonals will bisect at 90, which means 25 will be split up into 12.5 and 12.5. Let now the center be O. Now I need to find out QP. Okay, I know one of this. Now which two triangle will I consider? I'll go by similarity. Okay, where can I see a 90? So triangle CDO and triangle COQ. COQ is something in red. Okay, check that angle in red. One angle which is where diagonals are bisecting is 90, and triangle CDO. Okay, I need to find out QO. So I'm going with the triangle accordingly. CDO, something that is marked in the green. How can I make these two triangles similar? First, angle C is same to both of them. So common angles. One angle is same. I'm going by AA test right now. And one angle which is angle D is equal to angle O. Both of them are 90. That's it. Two angles are same. For these two triangles, two angles are same. So by AA test, I prove that these two triangles are similar to each other. If they are similar, all the properties of similarity will come. So side opposite to 90 in bigger triangle is nothing but 25. I write that. Side opposite to 90 in the smaller triangle is QC. I'll write that. Now side opposite to C in the larger triangle is nothing but 7. And side opposite to C in a smaller triangle is nothing but QO. I'll write that. Then side opposite to the other angle, which will obviously be equal, let that be alpha. So in bigger triangle, side opposite to alpha is nothing but DC, which is 24. Okay, and in the smaller triangle, the side opposite to alpha is 12.5. I need to know QO. That's it. I got it. 7 upon QO is equals to 24 upon 12.5. So QO is equals to 12.5 into 7 divided by 24. So QO comes out to be what now? Let's just multiply 12 7s are 84, 87.5 divided by 24. My QP, I need to find out QP. QP is nothing but 2 of QO. Why? Because diagonal bisect, twice of QO will be equal to QP. I write 2 into this, and now I just need to multiply this and get the answer. So I'm getting 87.5 divided by 12. If you divide this normally, you'll get the answer as 7.29, and that is the length QP. Okay, so I just applied the concepts of rhombus that I have learned, and I solved the question. Now let's take the next question. In this I get two rectangles. One is rectangle ABCD and other is rectangle APQC. One in white and other in yellow. What is given to me? The two sides of the rectangle ABCD is given to me. One is 12 and the other is 16. And I am being asked what is the area of rectangle APQC. I need to know its length and breadth. So let's start 12 and then 16. Nothing but Pythagoras triplet of 3, 4, 5. Multiply it by 4. 4, 3 is 12. 4, 4 is 16. 4, 5 is 20. It means the side of the APQC will be 20, which is nothing but the diagonal of ABCD. So I get one of the side of the rectangle APQC is 20. I need to know the other side to know the area. Let's consider this two triangle now. One in red and the other in green. Okay. How can I prove this two triangle to be similar so that I can get the side of APQC? Now let's see, one angle is 90, which is quite clear because it is at a rectangle, right? So one of the angle is 90. So in CBD, which is in red, and APB, which is in green, I know one angle is equal because it is 90. I need to prove the other angle which could be equal so that I can prove them similar by AA test. Now I am forming a Z here. First chapter, lines and angles, we studied something called as alternate angles. Now how do you form alternate angles? Just form a Z there. As soon as you get a Z, angle A will be equal to angle B. Why? Because they are pair of alternate angles. Okay, that's it. So I proved triangle CBD and triangle APB are similar to each other. So similarity will follow. So side opposite to 90 in CBD is 20, side opposite to 90 in APB is 16, so 20 upon 16. And side opposite to alternate triangle I'll take, so that I can find the side of APQC. So side opposite to red triangle is 12 and the side opposite to green triangle is X. I need to find X and then I'll get my answer. So that's it. I'll get X as now this is 16 into 3, 48 by 5. That is the side of APQC. Now the sum is solved. What is the area of APQC then? Length into breadth. Length into breadth. I know what is one length? 20. So 20 into the breadth, which is 48 by 5. If you just multiply them, you will get your answer. So answer comes out to be 48 into 4, which is 192 is the area of APQC.